All right, so for what it's worth, I am recording these things and putting them on YouTube so that way if you didn't keep up with note taking or whatever, you can look at it, or if you have trouble falling asleep at night, it's always helpful. Um, so um, before going on with today's activity, other questions? Yeah.
One question. In the homework, you say that we have to do a push and commit daily to get full credit.
Yeah.
That's probably good for some people. It's not really feasible for me. Is it? I mean, how much are you talking about? You don't actually, because
All right.
I do usually do most of my work in 1 or 2 days a week.
Right. So here's what I want to avoid. I want to avoid people doing this stuff just the day before it's due, because it just doesn't. You don't learn anything that way. This is not like Psych 101 or something. You really do have to have your brain occupied with this thing a few times a week, and so it doesn't have to be long. It could be half an hour here and a half an hour there. That is much more effective than trying to do it in 4 or 5 hours at the end of just before the due date. So I'm really trying to get people into that mode of thinking. And the reason for that is that when things go wrong, they usually are not really difficult things, but they can take hours to resolve. And so I have a lot of students in beginning classes who don't really know that, and then something goes wrong, and it takes hours to resolve, except those hours are no longer there because it's a few hours before the deadline.
Right.
And then they just never learn anything. They don't even get to the point where they start thinking about the things that the exercise meant them to think about. So it really is essential to do a little bit of work multiple times a week. And so you can prove me wrong by doing everything 3 days before it's due, and I'll be happy with that. Just check it 3 more times, right? That way it'll work fine. But I just don't want people to do it the last minute. The other thing that I don't want to do, quite frankly, and again, if you do it 3 days before it's due, then that's fine. But I don't want to see that, particularly as things are going to get more complicated during the semester, I don't want cheating. I don't want to see that there's nothing at all going on until Friday night, or when it's due? Wednesday night, right? Until Wednesday morning, and then the correct solution magically appears. Right? So I want to see a few steps that show how that solution was arrived at in a reasonable way. The third thing is I really want you guys to practice how to use Git. And this way you'll practice that. So humor me, and like I say, if you really feel you can do it in one fell swoop, you know what you're doing, do it a couple days before the deadline, and I will not question it. And that way you can do it once a week. Yes?
Second question.
Uh-huh.
I see that you uploaded the homework one scores.
Yes.
What is submitted into groups /
All right.
one?
I see. So hang on a sec. So let me pull up Piazza, because that's the next thing I wanted to talk about. So this is the first time that we're doing this this homework grading, right? So everyone gave me a repo, and so that worked beautifully. And so I've checked everything out. I've then graded a part of it because I've actually gotten a grader, and so the grader is going to run a script that grades your code. There's no value for me to add there with this simple program. And so I've looked at all the other things. And so there's a form that I filled out for everyone, and that just checked, did you put in your whatever that text file was? And I looked at the text files there just in case there was a personal message. And one of the things that I complained about is that text file was not actually in plain text. There are a few people probably who are using the text edit thing on the Mac that by default saves as RTF. So turn that off. Make it so that it saves in plain text. The world runs on plain text, or maybe markup. The next thing is I wanted to make sure that everyone has their stuff in the right place. So it's just supposed to be in a directory called lowercase h, lowercase w, number 1, in the root of your repo. And the reason for that is, think of the poor grader. The grader gets paid 2 hours a week to grade your homework. So the grader can't really do anything unless, yes, and minimum wage. So that's all that the grader gets paid. So for the grader's work to actually work out at all, he must be able to just run a script. And what's the script going to do? It's going to loop through all of the 29 students in the class. For each of them, it's going to CD into the directory, run CD into the HW1 subdirectory, run Java-C, run Java, pipe the output into some file that he can then look at, and go back to the parent directory and keep on going with the next student. If the directory is not called HW1, then what's going to happen? Well, the script will fail. And then we have two choices. I could either say that's 0 points, or the grader can just spend the 2 hours with the 4 or 5 people who didn't rename the script right and give it and not be able to do anything useful. So it's important that everyone just plays by the rules. But so what you want to do now in order to get those points for those remaining points for homework 1 is figure out how to use Git to move the directory. So the command is git mv, and that way you can move a directory, and then Git knows what you're doing. Next time you do a git push, then the repo is updated with the new directory in place. If you use just the move command either in the terminal or by using your file explorer, then Git won't know about that, and it'll get utterly confused. So don't do that. So anytime you make a structural change to your directories or to your files, use things like git add, git move, git remove, and that way Git knows what's going on. Yeah?
What if you change the file name of the root of the folder name of the root of your repo? Does that matter at all?
That does not really matter because that's outside what Git knows about. So if you look carefully in your file system, in fact, let me show you that. That's a really good question. So I have all of this stuff here in a Dropbox, and so if you see here, here's one of you lands, and you see there is a .git directory that contains everything that Git knows about your repo. So for example, in git config, it has the name of the repo and stuff like that. And the point that I want to make is this thing sits inside this directory, which I have named Barrett_Lance. I'm pretty sure Lance has called it something entirely different. And so you can call it anything that you want. Git never looks outside the directory that contains .git. So you can look for the .git folder, and anything that's out there, you can name it anything you want. But that's a very good question, because people do sometimes rename those. Anything that you rename inside, so if I were to now take it upon myself to change this one here into lab 2 with an uppercase L or something, I would not want to do that with the File Explorer. Anything that I do with the File Explorer, Git has no way of knowing. I would want to go in there with the terminal and use git mv. Yes?
What is you said Puerto Rico and you put HG.
Oh, that's a typo. HG is a different version control system that I use for other projects. Thank you. Yes, thank you. Excellent. Other questions? Yeah.
I think actually I also submit the Bitbucket link to you, but I think maybe you check out the GitHub one.
Then send me a private email. I thought I fixed that, but I don't know.
All right.
Yeah, so if you think that I checked out, oh, you will know what I checked out because that's why I put the file back in. So if you find a file hw1 scores.txt inside your directory in Bitbucket, that's what I used. If it's in GitHub, that's what I used. So if you switched repos and I used the wrong repo, let me know. There were also a couple of people who didn't make me, who didn't allow me to write to their repo. If you want scores, you have to allow me to write to your repo. Also, you need to add on the grader so that the grader can read and write your repo. Now you might say, well, what if the grader wants to sabotage you and write bad things into your repo? Well, it's a repo, right? It keeps a history of everything that's been happening, so you don't have to worry about that.
Do we need to submit our homework to the repo as well?
Oh yes, absolutely. So you will use this repo for every communication that deals with homeworks or labs or exams. You're going to be submitting your exams onto this repo. Okay, that way you'll never have to submit anything via email or via what's that other thing, Canvas or any of those things. Okay, other questions? So it is important to me that all of you get this mechanic straight. It sounds boring if you already know what you're doing, or tedious if it's all new to you. But once we are in our group project, being able to do this quickly is a total lifesaver. Like I said, before I enforced this, people would forever run around with a USB stick or email each other the quote-unquote latest version, and it was always a disaster. All right. So let me just jump into what I want to do, and then follow that up with whatever we may need. Here we go. Okay, so I'm going to start with this question here. And so give me a minute. I will now put what's called a clicker question into Piazza. And you can read through the question while I'm doing that. And you can also all fire up Piazza because you'll need it. They are? Then I must have copied it wrong. Let me double check. Oh yes. Okay. Well, this is where it now comes in handy that I can write on this. Okay. What I mean is this arrow. So answer the question that I mean, not the one that's on that. I'll fix it a little later. So go to Piazza and just answer 1, 2, 3, or 4, depending on what you think is right. We'll be looking up on the Piazza app how we're doing. So far I've got 2 answers. Two different answers. Yeah, if you don't know, by all means, ask your neighbor. I'm totally fine with that. All right, well, the last ones are wrestling with this. So let's demystify these things here. What does this arrow mean? What does the first top arrow mean?
It's direct association.
Okay, it's in plain English.
Has.
Okay, let's ask someone else. What's the top arrow mean? Okay, let's see what we had in our slides. Oh, I see what I did wrong. Are they dashed? Can you revote?
Most people voted for that one anyways.
Okay, well, no, but that's okay because I'm not super serious about it. Yes, so I messed this one up. So you were correct with the direct association. What I wanted is just use this, so my UML is just as rusty as everyone else. What is this one here?
Association.
That one is has, and then this one here is. Okay, so let's see how people voted. And so I just wanted to close the darn thing here. Close. Oh. All right. So the majority of the people said that the uses is the correct relationship. A bunch of people said it's has. And there were one person who thought it was inheritance and one person who said they had no idea what the homework was about. So let's first of all see what's the right answer. So we have a user. One person said, yeah, she didn't use the user class in the homework. The homework assignment does say to use a user class. So in the homework, we're not doing the phone system. We're doing this mail system. And in the mail system, there are users. The users have usernames. They have passwords. And so it was the user who has the password, and it seemed appropriate to me to make a class user. In the telephone system, it's this mailbox that has the password. And it's a philosophical question here. Should a mailbox have the password of the user? But I wanted you in the homework 2 to take the attitude that user is something that we want to model. So if you haven't yet modeled users, go ahead and start modeling them. So now it certainly is true that a user is likely to be manipulating a mailbox. What is it though? What does that actually mean? What that means is that somewhere in the code that you haven't yet written, but imagine that the code at some point does exist, somewhere in the code it says a user some method that would be one way that user could use the mailbox class. So keep in mind that using doesn't mean using in the sense of carbon life forms. It means in the sense of code. So, one of these 11 people, give me an example of what this method could be. Aha. Okay, so that's excellent. So, okay. And so she's saying this could be the read method. So somewhere in the code, there's going to be a user, and that user is going to execute a method called read. What's it going to do? What's that?
Would you need more parameters? You're not.
Okay, absolutely, totally. Maybe I need more parameters. What's it going to do?
Print a certain
Okay, so now it would print and say, well, what would it print?
data.
The messages in the mailbox, if anything.
Which message?
Exactly. All
The
the
parameter,
It doesn't
the
make
second
sense.
parameter would be the index. So it might be.
I see. So okay, so now you're saying the index of the message, and I will just print the message. And so, but why would you have the user in there in the first place? Why not just make this a responsibility of the mailbox? What does the user add that the mailbox by itself can't do to accomplish this task?
Each user should have a separate mailbox.
I'm not disagreeing with that. So I'm just saying that this read method looks fishy to me. Because we're giving it three pieces of information, the user, the mailbox, and the index, where I don't think it actually needs the user. And so this read method is probably not on the right track. Now, I don't want to pick on you, and I'm grateful that you volunteered something, because it's useful for all of us. This happens all the time. That someone says, oh, I think this would be a useful method. And it takes skill and dedication to beat that down to say, well, that actually makes no sense. But why is it good to beat it down and say that makes no sense? It saves a lot of time. See, now we can quickly beat up the bad ideas. Later, once they are there in code, ask yourself, if you have spent 2 hours coding up some method that later on turned out to be clumsy, are you really going to zap it? Hopefully, yeah, but I mean, in reality, if it kind of creaks along, people are very reluctant to do that. So I'm sorry, I cut you off. You want to say something?
Oh yeah, I'm still unsure what the purpose is of the user class because we could easily assign the username and password to the mailbox.
We could. We absolutely could. And this is something that always happens with this design. That at some point, one has to figure out what one wants to do. And so we could absolutely have the mailbox have a username and have a password. But in this particular design, I'm making you make the assumption that we've settled on a user class. Yeah.
I kind of went through that same questioning process.
Uh-huh.
And really, I think from the requirements you've given us for this particular
Yes.
assignment, it's kind of superfluous or not necessary, but
Yeah.
it has the potential to, if you later
Yeah.
decide, well, what if one user wants to have multiple mailboxes,
There you go.
then it makes it a lot
Yeah.
easier to change.
Yeah, like Mrs. Clinton, right? So, so that would actually be an advantage of that design. And so what I intended to do, it may not have done in elegant ways. I wanted you to say, live with this part of the design that we're going to have a user class. So go and have a user class. And so all of you already finished with the homework, go back and change it so that you have a user class. That's a very common thing one needs to go through, so I'm not sorry if you have to practice. So we had one alternative that the user uses a mailbox, and you can make this work. And so I can think of a design where this works. Namely, if you, in your system, you have a collection of users, and then somewhere you have a separate collection of mailboxes, and then someone, presumably the mail system, somehow matches them up in some way. That's not the simplest design, because that matching up takes some amount of effort. So we might want to look at the second alternative. The second alternative is that a user has a mailbox. Now in code, that would look like this. Then you have a class user, and it would have an instance field. And I'll just call the instance field mailbox because I have no imagination here. And that would seem like a potentially legitimate design. Later, if we wanted to model multiple mailboxes, a user could have an array of mailboxes or a map from names to mailboxes or whatever. So that's also a possible design. That one to me seems fairly simple. That way when a user logs in, the mailbox, and one has identified the user, then one can just ask the user, hey, what's your mailbox? And then one can start using the mailbox. So, but either of the designs can be made to work. So you would use uses if the mailbox is stored somewhere elsewhere, and if there in fact is a method where the user uses the mailbox in some way. There's a third possibility. Oh, first of all, before going to the third possibility, the inheritance that only one person picked was a red herring, right? It makes no sense to say that a user is a mailbox. Right? First of all, from an anthropomorphic position, it makes no sense, of course. But more importantly, from a coding question, it makes no sense. You're never in a situation where you have some mailboxes that are just plain old mailboxes and other mailboxes that are users, right? A user is not a special kind of mailbox, and you wouldn't use inheritance and polymorphism before that. So there is another possibility that I didn't list, and that is there might be no relationship between them. I could imagine a system that has a collection of users, that has a collection of mailboxes, and where the system does everything, where the system looks up the user, the system looks up the mailbox, the system makes calls to the user, the system makes calls to the mailbox, but the user and the mailbox don't know of each other. I could imagine such a system, yes.
Is that conflict with the console?
What's that?
The console?
No, we'll come to the console in a minute. So, so you can imagine a system like this. I'm not sure it's a very good system because it seems the mail system now has to do an awful lot of work, and so it would not be my first choice of a system. But it is a possibility. So, which of these answers was correct?
First.
Certainly, the first two, can be correct, depending on what was going on in your head as you were doing the design. And the third and fourth, no, not so much. So at this level of the design, there's not necessarily one right answer. And it's an important thing to keep in mind. Okay, I'll come to the console question in a minute because we do need to talk about the console. I want to explain a little bit what you've just seen here. You've just seen a so-called clicker question. Have you ever used clickers in another class? These little hardware devices where the professor puts a PowerPoint slide and you have like 4 options and you're supposed to choose 1 through 4? It's a very popular thing these days. The theory is that if a professor lectures for 75 minutes, I should have a clicker question of that. So when you sit in a lecture as a random normal student, approximately after how many minutes does the normal average student stop paying attention?
20, 3.
Oh, pretty good. So I have 15 and 20, I think. The average, I think, is 19. So after 19 minutes, you can basically forget. And so the way to counteract is not to ask a question every 15 minutes, or even more often. And asking a question is tedious, right? You've seen me do this. I asked a question. It took minutes before everyone logged onto Piazza and actually put on the answer. So these hardware clickers are there to make that a little bit faster. Everyone has the clicker, gets out the clicker something, and that's the end of that. So the disadvantage is, of course, it's a special hardware device. And so in the design lab that we're going to be doing in a few minutes, you're going to be imagining how to implement that in a different way. But before doing that, back to the console. So when you do these kind of things that have a user interface, you always have this problem that you have the domain classes. And for us, that would be the user, mailbox, message. And what you want to achieve is that these domain classes here, that they are completely neutral as to the user interface. So in the context of our little project here, don't print, don't scan in any of these classes. So there was we just had this discussion about what the read message should do, and one of you said, oh, it should print this message. No, it shouldn't print the message. It could reveal the message as a string. That's fine. Or if you want to add a message, someone who drives these classes should construct a new message object and add it to the mailbox. That's fine, but there shouldn't be something here that says system.in or something like this. So these ones should not be coupled. They should not use system.in, system.out, print stream scanner, and so on. And so you want to have some kind of what's often called a controller that deals with the user input and output. And in this application, I'm calling it the console. So the console does depend on system, print stream, and scanner. And then what you typically want is that the console uses the mail system in some way, and then it drives the mail system. And then the mail system uses or has, uses is never wrong, these classes. So there's one method that the console definitely will have, and that's, I think I call it run. That simply runs the whole simulation.
Is that going to be the main method as well?
Oh, there's going to be some driver that, if you look at the phone system, there's some class, the tester or so, that makes the phone system and calls whatever on it. That's the same thing. So you would have a separate class that just kicks off the thing. That's just an accidental thing, right? In reality, the systems never start. I mean, like Google Mail doesn't have a mail. And so the job of the console is to print out that first message that says, welcome to Chatterbox, or whatever the name of that thing was. And then it's supposed to ask you, then it's supposed to do the login thing somehow. And then when it gets a username and password, then it can go to the mail system and say, hey, mail system, someone wants to log in with this string as username and with this string as password. And so the mail system only sees strings. It does not see any system.in or system.out. Yes?
In the book example, what was the purpose of connection?
So the connection was pretty much the same thing as the console. The thing is, the book had the additional complexity that there was this telephone thing. And we don't have the telephone here because we're not trying to drive to simulate the actual keys on a 12-key telephone pad. So you could think of the connection as the console as you could think of the connection as the telephone and here's the console as the connection and the telephone rolled into one. Yes.
So the console would ask the user or the
human. Yes.
the human, give me your user and password.
Yeah.
And it would check within its list of users to see if it has that username and checks if the password is right. And
Exactly.
then it would. Okay.
Yes.
Here's like the console depends on the mail system, and mail system depends on.
Well, that's a good question. Does the console depend? Does the mail system depend on the console? The console definitely needs to depend on the mail system because it has a mail system somewhere, and it tells the mail system, "Hey, someone claims to be this user with that password." But does the mail system know anything about the console? See, that's the beauty of this. I should later be able to slice things off here and put a graphical user interface
It's
or a
like-
web interface without changing any of these domain level classes.
So if we consider this as a MVC, so which part is like model?
Well, we're not quite there. So this thing is certainly the model. So that part is easy, but I don't want to get into discussion on whether this thing is. There's no view there really, right? So I guess if you wanted to, you could say this is kind of mostly the controller, but it's not really quite the same thing. Yeah.
In the case of like the CRC card, the design process like that, do you usually ignore like fundamental classes that are outside of the scope of your project?
Yes.
Such as like system.
Yeah, like you would not make a CRC card for system or scanner or string or date or any of those things because there's nothing to be gained by modeling those. So let's, in fact, and this is taking me much longer than I thought. Sorry about that. We'll just get started with this, and we'll keep on going with it on Thursday then. So I want you to do that CRC process yourself. And it's because it's such a weird process that one really needs to do it as a group. So we're going to split you guys up into groups of 3, and there are 3, that all goes well, 3. Seems to be mostly working out maybe with a couple of 2s left, one group of 2 left. And so get together, grab a marker, stand up at one of those whiteboards, and start with the first step that one does, namely to make a list of classes that you would need to do a clicker program. So in the clicker program, we want to do a clicker question, like lots of clicker questions, like these here. Except we want to save the student from having to pay another $30 to buy a clicker. So we're going to be using what everyone has and holds in their hands at every minute of their life, namely their cell phone. And so we're going to be designing a cell phone app for that. So imagine how it works. So on a regular computer, presumably, because it involves some creation. The teacher logs in and adds a problem with a description and a few choices. One of the choices is correct. And then when the teacher has done that on the web page that all the students can see here, on the projection screen, then the system displays some code, some whatever many digits code. The student then goes to their phone app, types in that code so that they're answering the same problem. The question then, does it get displayed? You can choose that, but the important thing is then on the phone it shows 1, 2, 3, 4. The student presses the answer, and that's that. And then the teacher, wants to know a few things, like how many students have answers. You've seen me do this. I wanted to know very badly how many students answered. Why? Yeah, it's
Feedback to check on.
yeah. Remember what happened? I kept checking my phone here, and I kept reloading that screen. I said, now 13 people answered, now 14 people answered. But I wanted to get the last damn slacker to answer that damn question, because these things only work if you get most of the class to play along with it. As you've noticed during today's class discussion, there was some very good feedback here from the first row, not so much from the row back there, right? And so one of the things that this technology is supposed to do is make sure that everyone pays attention during class and not just the people who sit in the first row. So I looked at, at least 90-95% of people have tried to put in an answer. And particularly when I have a large class, like with 150 students, then that's really, it's amazing how it happens. It starts off slow, you very quickly get to about 100, then you kind of get to 120, and then it takes forever to get the last 30. The first time. After a while, everyone gets the hang of it. Okay. Then, of course, I want to know the number of answers for each choice so that one can get this little histogram. And finally, I would like to know, who is this person who didn't even know that there was a homework assignment? So that's the kind of information that I want. So go forth. I'll give you markers. There's plenty of whiteboards. Take ownership of a bit of whiteboard. And right now, all I want you to do is come up with a collection of classes that you think we're going to be using. I don't think that we're going to get to any more than that. Yeah, you can have a couple of things, to fight over them. Okay, try to share it. We have. We have quite a few back there. Up here. Okay. You have a group. Yeah. No, do it on the board. Do it on the whiteboard. That's the way to do it. People do this really. Take a laptop and you can remember so it's what you could do is you could prefer it. I try to get them to install the thing that records what I write. It'll happen eventually.
We need like some sort of yeah. So the clicker system would have so right now I'm just gonna say it has two jobs. To obtain data. And to work with the display. Right?
Oh, yeah, right.
And the users.
This would be the main class. This we read.
These are the three jobs that send it to the system. So we have there's like a driver on top. It's like it talks. It's like a test. This is what runs. So the system would have would have an array. Each user would have like a preview maybe if the teacher is true, if the teacher is small. And then
Unless you're saying user. So the problem was probably it's gotta be.
but the problem is also in so it would manipulate the system's problem by giving a code.
All right, could you guys come to an end and take a photo of what you have done with your camera?
There were no cell phones. I guess you would just turn in a bunch of papers, huh?
I don't know. Was there such a time? There were always cell phones. Yeah, so take a photo of whatever. It doesn't have to be perfect. And then when you have that photo, just share it with each other somehow, or each of you take a photo and put it on your lab report. That's all I want for the lab report. Because I want to, then you can sit down. Yes, leave it there and all this.
Yeah.
All right, everyone has a photo? Okay, then let's sit down and let's have a look at what's going on a bit.
Because they're gonna have a whole bunch of responses. You just have to collect them.
All right, so what we're trying to do here is to, it doesn't have to be perfect right now. You'll get plenty of chances to perfect it. So what we're trying to do here is go through this design phase of this mini methodology in the book, right? So the design phase says, in step 1, we want to identify classes. And so all we need to have for this part is a textual description of the classes and a few key methods. And so here it says, rule of thumb, look for nouns in the problem description. Here it says focus on concepts. And then it goes on with some responsibilities. So right now, I didn't think that we were going to get very far into the responsibilities, so we just want to look at classes. I didn't even ask for relationships, so everyone raced right into the relationships, the third part of it. Normally, before one does that, one does the CRC card step. So I was just kind of hoping for just a list of classes. But I can work with what I got, so that's fine. So here we have class of student and teacher, and someone said correctly that there are two kinds of users, namely student and teachers. It's a good idea here to use the proper UML. After a while, this becomes second nature. That's so that when someone else looks at the diagram, they know this means inheritance. Students are users, teachers are users. So I think we have the same phenomenon here, right? Here we have, so the arrows are the wrong way, but that's the question.
You're right.
Yeah, just have to memorize. Yeah, and it seems a common thing. No big deal, right? So now let's look at this one here a little bit more. So here we have a class problem, and that certainly makes perfect sense, right? Because one displays a problem, and so we have that here. Here it's called question, and here that certainly doesn't really matter what you call it. So over here we also have question, and so now when you go over, where was it? Here, so someone has that a question is a set of choices, and so this is something where we get into, where one starts making interesting decisions. So should a choice be a class? And so you answer yes. So why should a choice be a class? What's the alternative? Like over here, there's nothing for choice.
Response.
The choice is.
What do you mean by choice?
Okay. That's a good question. So maybe there's no. This is what I mean by choice. This is a choice. This is a choice. This is a choice. And this is a choice.
So which one do you pick? In other words,
Like the
the answers, what the possible answers are.
yeah. So that was what I thought what a choice is. Maybe I misunderstand this one.
No, that's what it
What
is.
did you guys think? What was this choice?
Yeah, that's what it is.
Okay. Yeah. And so you can make it into a class, or you can. What I thought over here, you guys didn't make that into a class.
Part of the problem.
That's just a part of problem. And so why did you just make it a part of problem?
We didn't do that too much.
That's really one way. I'll give another way of saying is, if it's just a bunch of strings, then why make a class for what's just a string? But the flip side is, when you look at this, this seems to be more than a string. There's images and whatnot, so maybe it's rich enough that it's worth being made into a class. So it's a judgment call, which of the two you do. And so it also very much depends on what is the lifetime of this design. Is this for a homework? If for the homework, you never need any more than text strings. It may not be worth the cost of having an extra class. If it is for something that you want to grow over years and years, then you might really want to say, well, choice might be something that's richer, that has images or whatever else. You might want to have equations. So you might or might not have the choice here. One of the things that is characteristic of a problem is that it has a correct choice. Right? There's one and only one answer. Or is there?
Could that be attribute?
That would be then an attribute, yeah. It's not so clear whether there is or there isn't. I think the problem description, it did say one of the answers is correct. There's my problem description. Yeah, and several choices, one of which is correct. Right, so that would at some point become a potentially useful attribute of this here. Not clear that this is actually good modeling, because in my example question here, there was no one choice, right? You could have argued for several choices. And so, in fact, when I make clicker questions personally, I try to make them so that sometimes no choice is correct or more than one to increase confusion and engagement.
But excuse me.
Yeah.
Would you prefer to create a class for the options or just keep them?
It really depends. So there is no right answer, because it depends on what is the scope of this project. So if it's a homework that you need to get done in 2 weeks, I would say you don't want to model every last aspect of the world. At some point you want to say, the set of question has a bunch of strings in it. If on the other hand, this thing is supposed to live for a long time, you might want to, for example, say, I want to have the choice of randomly shuffling the options. Then it would be kind of good to have those options, as things that have their separate identity. So that's the beauty of this here, that it's not so easy to falsify these particular designs. But let me try. So here we have this whole system here, and we have these responses. And so response is an interesting thing, right? So who gives the response? The student gives the response. So now imagine we have one of these response objects. What would the response kind of have to know about? Who gave it? And what problem, right? So when I look at this design, I would feel a lot happier if somehow the response knew about the problem and it knew about the student. That would make more sense to me. Right? Somehow and it could even hold a reference to it. So if someone argued, well, it actually has to have a reference to this. I would say that makes a lot of sense to me because when you have a response in your hand, it has to know what it is the response should. Now, one could always argue, well, maybe the whole system has a huge old hash table that is keyed by IDs, like you would store in a database, but that's not normally how one approaches an object-oriented design. You normally want to have these objects to have all the information that they need to function relatively independently. So the response is a tricky part of it. Let's see if we see some other responses here. Okay, so I don't see a lot of other responses. But okay, so it looks like that proof that was the only one who came up with the concept of the response. But I think the response is pretty important, right? I mean, the response is something you want to collect the responses, and so that seems to me like an important characteristic that Monkey did not do. The other thing is, so I see here the statistics, and over here there was another one that said statistics, and that may be a good design, or it may just mean that we can't really think about anything right now, but it's all got to be. And either way, it's nothing is wrong that in the first phase, just kind of put it in there as a placeholder and hope that it'll crystallize later. Or you might really want to say, I'm going to rigorously somehow put all the statistics into the statistics, but that might be hard, right? The statistics might have to know about a lot of things. It's nebulous what statistics does. So when you have a user, you can imagine a user, you close your eyes and you know what's a user. What is a statistics? It's hard to say. And so that means that you definitely then in the next phase with the CRC card, you want to flesh out what is this responsible for. When the cards have statistics, give me all answers, then you have to think more about it. But it can be a sensible way of doing that if one understands exactly what it is. All right, so I wanted to go through this exercise so that you get a gut feel for how hard it is. It's harder than you think to come up with a good design in 15 minutes. And so for the homework, I hope you have some idea of what I'm after. So I would like to have the CRC cards that have the responsibilities. And so that way, when you come up with something that's a question or a response or a statistics or a GUI, seeing what it says on the CRC card, what the thing is supposed to be doing, is going to give me a lot more information about what your thinking is behind that. So I want to know, what is a user supposed to do? What is a mailbox supposed to do? What is a message supposed to do? Of course, you can be guided a lot by what goes on the example in the book, but there are some definite variations. If you have questions, if you find something confusing or nebulous, put the question on Piazza. Okay, so homework is due tomorrow midnight. Any last questions?
Haven't checked in this week.
What's that? Well, check it in now.
Yeah, for daily.
Yeah, check some stuff in. Just get in the habit. All right, I will see you on Thursday.